Welcome to Back to School Night in the Engineering Lab. Hi, I'm Mr. Piccioni, and I teach STEM engineering, engineering systems, and robotic systems here at Chantilly Academy. Welcome to Back to School Night. If you have any questions about the classes I teach, please feel free to email me at mspicccione@fcps.edu. This is my third year teaching at Chantilly Academy and my 21st year teaching overall. I graduated from the Virginia Tech with a master's in education and technology. I really enjoy teaching technology and engineering courses. Parents, you can best support your students by making sure they check their Schoology site and keep up to date on their assignments. While they can't share their engineering notebook with you, you can keep track of some of the assignments they've viewed or turned in on Schoology and ask them to show you some of the content they've worked on in class. Here's my Schoology page. All my Schoology pages for each class look the same. They have a folder for student opportunities outside of class that relate to internships, jobs, scholarships, competitions, and other things. A folder for class materials that aren't related to a particular assignment, and then the Start Here folder. Within the Start Here folder, they have the syllabus for the class, my office hours, and to kind of welcome to class and how class works letter, explaining how my grading system works in all my classes and what I expect of students. A discussion topic that students can put questions on if they have questions for class that aren't related to our particular lesson we're learning. And then the calendar, either broken up into units or months, explaining what's going to be covered. Here we have our classroom, where we can see we have a whiteboard and smartboard, and some of the technology we have in the classroom. We have laptop computers for students if needed. A library edition. We have flexible seating up at the front of the room if students don't want to sit in chairs and would rather sit on mats and use clipboards. And then we have some storage in the robot arm, which we'll use in robotics. Here's the shop with the woodworking area, the metalworking area, and some heavy-duty tools like the table saw. In STEM engineering, we've started to develop our workplace readiness skills by working on our notebooks and completing a presentation. We'll continue to work on workplace readiness skills and learn about the design process and what it takes to be an engineer as we complete a career project in September. In October, we'll learn about electronics and electrical components and microcontrollers while we work to build a small circuit that's able to make light and sound and possibly movement so that students can put the entry into the Chantilly Haunted House if they so choose. In November and December, we'll study the physics of engineering and look at statics to complete a statics project, instructional analysis. After Christmas break and in semester 2, we'll get into simple machines, cover CAD tools like Onshape. We'll learn more about rapid prototyping and 3D printing and tool safety. We'll also work to complete a woodworking project and a metalworking project using some of the tools in the shop you saw earlier. If we have room at the end of the year, we'll work to complete a robotics unit and an aerospace unit and complete a 6 weeks engineering project. This class provides the basis for other classes in the engineering lab. After STEM engineering, they can take Engineering Systems 1 or Robotics. In Engineering Systems 1, we'll follow the E4USA curriculum developed by the National Science Foundation, Virginia Tech, the University of Maryland, and Arizona State University. We start with learning about how to be an engineer, with a few units on all about engineering and where we see engineering in everyday life. Then we learn how to use the engineering design process to develop some activities as we improve our skills. This class is all about using the engineering design process to become a better engineer. I often tell the students it's like AP engineering because it not only has honors weight, but it also allows them the ability to earn college credit once they graduate and apply to a college that also uses the same curriculum. In Unit 2, we learn more about sketching and prototyping, and we'll learn to use more CAD tools like Onshape, which is a continuation of what they did in STEM engineering. In Unit 3, we learn all about empathy as we design things for others. And we learn how to really understand the engineering design process and write a research paper, which is displayed in Unit 4 through presentations and sharing with others. Units 5, 6, and 7 aren't on my Schoology site yet, but they're all about continuing the engineering process and developing things for the community and engineering projects for themselves. After STEM engineering, if the student is more interested in technical classes like robotics, they can take robotics systems, where we start workplace readiness and learn about systems engineering. We'll then get into more CAD tools, learning Onshape and rapid prototyping and 3D printing. We'll get into shop safety because we use the tools in the lab a lot in robotics. And we'll do an advanced tool usage project where they carry over what they learned in STEM engineering into robotics. Then we learn about robotic systems and all about mechanical power to include fluid, pneumatics and hydraulics, and then electromechanical. Around January timeframe, we'll look to complete a 6 weeks engineering project and learn about advanced industrial robotic control, learning how to use the FANUC iMate robot arm. If they continue well with the iMate robot arm in level 2, they can earn a certification using that. Towards the end of the year, we'll get into more electronics and programming, and they'll build their own little robotics project along with many other activities, and we'll possibly have time to learn MATLAB. If students take level 1 of either engineering systems or robotics, they can take systems level 2, which is more of a small group class where students can work towards projects geared towards the engineering class they took previously. We'll again go over engineering basics and review and shop safety in the beginning. Then we get into advanced CAD and rapid prototyping tools and learn how to do some very detailed stuff using Onshape. We'll learn advanced technology and learn all about CNC machines and more about rapid prototyping and the product lifecycle. We'll introduce mechatronics into our engineering projects as they get more and more complicated. We'll complete 2 technical reports, one on materials and one on a device, as we complete different systems engineering projects. We'll complete an advanced manufacturing process as we learn all about fundraising and developing ideas that are to sell. We'll do advanced circuit design, and they'll make their own circuit boards and build an electromechanical device they take home. They'll also apply MATLAB towards the end of the year as they really learn to hone their skills in this advanced engineering class. Students aren't always able to take the advanced level classes due to other things in their schedule, and that's okay. I enjoy having them in class, and I look forward to learning more about their personalities and showing them all that can be done through engineering.